Okay, let's start with a brief overview of the processes that influence weather and climate. And one thing to be mindful of is that the processes that affect the climate of the world and of California, they're operated at different scales. There's global scale patterns of temperature and precipitation. There's also local scale patterns that are influenced by local topography and landscapes. And first, we should define a couple things. Weather and climate are not the same thing. Weather is actually what happens. It is a short-term condition, the actual temperature, rainfall, and so on. And climate is more what you'd expect. It is the average of weather over a long period of time. So if you take weather records and average them over a long period of time, it tends to smooth them out and gives you an idea of what you would typically expect. Weather is highly variable, and can, with a lot of, and can change from week to week, day to day. But climate is a more of a stable measure that we use to understand the general properties of different places in the world. Now for both, the two main things that we look at for weather and climate are temperature patterns, how hot or cold things are, and also precipitation patterns, how wet or dry things are. And there's a bit more to it than that. There's temperature, and moisture is precipitation. And we'll also talk a little bit about what we call pressure systems and wind systems as well. But if we're focused on temperature and precipitation, let's look at a few things that affect them. One is latitude, how far you are north and south of the equator. So it's hotter near the equator and it's colder near the poles because of the sun angle. Also, some latitudes are dry and some latitudes tend to be wetter environments. We'll talk about why that is. There's also position within a landmass that you have what we call land-water contrast, because land and water heat up differently. Coastal locations are going to have a different environment than what we call continental locations far from the ocean. And then ocean currents will play a role as well. These make differences between east and west coasts. And lastly, elevation in a local environment plays a role. The higher elevations are colder, and mountains tend to have wet and dry sides to them. So on a global scale, temperature patterns are influenced by latitude. You have more direct sunlight near the equator and less direct sunlight at the poles. This results in hotter environments near the equator and colder environments as you get closer to the poles. So for example, in California, the southern part of California gets a more direct sun angle than does Northern California. Thus, Southern California tends to be warmer as far as, depending on elevation or whatever else. But overall, it tends to be warmer in the southern part of the state than in the northern part of the state where the sun angle is lower. You also have variation by latitude in how wet or dry things are. And this is gets a bit more complicated. So we'll have a separate lecture where we talk about pressure and wind patterns. But essentially that some latitudes tend to be wetter than others because of how the air is moving, where air is either lifting at the equator causing wet conditions or going down or descending at what we call the subtropical high causing dry patterns. So latitude plays a role in how wet or dry things are as well. And if you kind of put these combinations together, that different latitudes have different combinations of being either hot or wet at the equator, hot or dry near 30 degrees north and south, cold and wet closer to the poles at 60 degrees north and south, and cold and dry at the poles themselves. Latitude also affects seasonality, that in the tropical areas near the equator, they tend to have less seasonality. It tends to stay warm year-round, where in the middle latitudes, we tend to have all 4 seasons. The middle latitudes are those parts of the Earth outside of these tropical areas. Okay, now, position within a landmass. These play a role in one sense because land and water heat up separately. So locations near the water will have a different have less variation in their climate than areas that are far from the ocean. So a quick example, if we look at a comparison of San Francisco and Wichita, Kansas. These are temperature graphs showing the temperature variation for San Francisco and for Wichita, Kansas. And in San Francisco, it's not very cold in winter and it's not very hot in the summer. By contrast, in Wichita, it's very hot in the summer and very cold in the winter. They're both at the same latitude and elevation, but the difference is that San Francisco is more influenced by the ocean than is Wichita, Kansas. And because of that, Wichita has a greater temperature range than San Francisco. Even in a local scale in California, so in the Southern California, Santa Monica has less variation in temperature, in red here, than do San Fernando and Pasadena. Even though they're in the same urban area, the fact that Santa Monica is near the ocean tends to give it a more mild climate. Ocean patterns play a role as well, that they tend to move in a circular pattern. This brings cold water off the coast of California, whereas East Coast tend to have warm water that migrates up from the equator. So this is called the California current. If you've been to the beach and jumped in, you felt it. It's very cold. And that's because of the pattern of circulation on West Coast is different than those on East Coast. There are a couple of just things to note about that. Because our water is cold off our coast, that inhibits or prevents things such as hurricanes or severe summer rains. So if you'll notice, these cooler colors are colder temperatures, these warmer colors are hotter temperatures. So on the East Coast, where the ocean is circulating from the equator, they have summer rain and also hurricanes, where we tend to have drier conditions in the summer and we're not susceptible to hurricanes. Hurricanes require very warm water and we just don't have that here. However, we do occasionally have something called an El Nino year. And what happens during an El Nino is that you can have a reversal of these ocean patterns and you can get warm water off of our coast, giving us a bit more rainfall than we would normally get. Elevation plays a role as well, that higher elevations tend to be colder than lower elevations. This is something called the lapse rate. So in the bottom part of the atmosphere where our weather occurs, as you move up in elevation or in altitude, there is a consistent drop in the temperature. This causes different environments. So for example, in California, we have climates that vary because of elevations in the Sierra Nevada and other places. So if you're going from Fresno, you would go through one type of a climate, and as you go into the Sierra Nevada, you would pass through different environments as you go up in elevation. So while Fresno and Shaver Lake are at the same latitude, Shaver Lake is where you can go find snow because it's at higher elevation. The elevation plays a role in precipitation as well, that here in California, our winds tend to move from the Pacific Ocean over land, and as they're pushed up mountains, the one side of the mountain tends to be wetter where the air is going up, and on the opposite side, you tend to have a drier rain shadow. So here, elevation can play a significant role in how much rainfall places get. So if we look at where we have high amounts of precipitation, it tends to be on what we call the windward side of mountains, those sides where the air is blowing against them. On the opposite side, we call it the leeward side, it tends to be much drier. So the part of California that's on the other side of the Sierra Nevada is much drier than this side of the Sierra Nevada. Also note too, if you're ever driving from Fresno to the coast, we're in a little bit of a rain shadow ourselves here from the coast ranges, and as you drive over, the conditions get wetter and wetter until you get to the coastal areas, which are quite wet.